The purpose of that module is to help you to develop a preventative maintenance program that supports your control valve life cycle strategy. This module will describe the different phases of the control valve life cycle. For each phase, we will be providing you with suggestive FIELDVUE settings and recommendations to realize the full value of FIELDVUE Instruments diagnostics. Valve criticality assessment. Startup and commissioning. Normal operation and predictive maintenance. Managing abnormal situations. Plant turnaround. All control valves in plants are not equal. During the first phase, you should assess the criticality of each control valve to determine how they should be monitored and maintained. Use the Fisher Installed Base Tool, IBT, as an enabler to understand critical versus non-critical and define diagnostic and spare parts management strategy. If a failure of a specific control valve causes a plant performance, availability, or safety issue, then such valve should be fitted with a FIELDVUE DVC Performance Diagnostic, PD. If that is not the case and the valve is on a severe surface application, erosion, cavitation, flashing, etc., then the valve should be fitted with a FIELDVUE DVC Advanced Diagnostic, AD. If not, then the valve should be fitted with a FIELDVUE DVC Heart Communicating, HC. Using AMS Valve Link or Valve Link Mobile, 1. Enable the triggered profile. 2. Configure the PD one-button sweep to run every week and PD friction every month. 1. Import valve birth certificate from factory. 2. Verify spec sheet and upload information into database. 3. Valve step response, full stroke. 4. Valve step response, performance test. 5. Total dynamic scan. 1. Set instrument date and time. 2. Clear alert event record. 3. Enable travel deviation. 4. Run status monitor at 0%, 50%, and 100%. Input signal in service and save each dataset. Monitor and report travel deviation. If instrument is PD, then monitor and report travel deviation and diagnostic available alarms. Verify on a monthly basis PD friction test results. Talk to operations for obvious symptoms. What is the problem? Valve won't respond? Oscillating? Alerts? When did the problem start? 1. Run status monitor at the current operating position. Check supply pressure, drive signal, and travel pressure state. 2. Compare current to baseline values to try to identify the problem. If instrument is PD, then 3. Check the triggered profile, run one button sweep. If one button sweep does not clearly determine the problem, run a valve friction test. If problem is determined and corrected, then return to monitoring phases. If not, then export diagnostic data and contact your nearest valve service center for support. 1. Run status monitor at the valve's controlled travel and save dataset. If instrument is AD or PD, then 2. Valve step response, full stroke. 3. Valve step response, performance test. 4. Total dynamic scan and compare with baseline data. Ensure output for control system is left at 12 milliamps and supply is available to the controlled valves. If integrity is good, then return to the monitoring phase. If not, then correct problem and/or export diagnostic data and contact your nearest valve service center for support.